Hello everyone, how to solve this problem for the values of x if we have a square root of x is equals to minus x, and we solve this problem for all the values of x. So here first we find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. So please watch this video at the end. Further, we solve this problem for two methods. I hope so you like both of these methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So in the first method here, our first target is to eliminate this square root sign from left hand side. So in order to eliminate this square root sign, we need to take the squaring on both of the sides of given equation. So after taking squaring, it will be written as square root of x and its whole square is equals to minus x and its whole square. So further, in the next step, you focus into the left hand side, and we have this 2 and this square root are gone, and we will get here x is equals to, in the right hand side we have this is the square of negative term. We know that when negative sign appears inside the square root, it will inside the square, okay, it will becomes positive. So this negative sign become positive due to 2, and we just write it as the square of x only. And now here further in the next step, we need to move the variable terms in any one side. So here we move this x to the right hand side. This is positive x. When we move it into the right hand side, it will becomes a negative x, and this whole equation is equals to 0. So further in the next step, you see here both of these terms involve x. It means that x be the common term. So after taking common x, we get here the remaining values are, from here we get x minus, from here we get 1 is equals to 0. And further in the next step, we divide this equation into the two cases. The first case is we write x is equals to 0, and the second case is we write x minus 1 is equals to 0. So this is our first root of the given equation, and from here we move this minus 1 to the right hand side, and we will get here x is equals to plus 1, and this is our second root of the given equation. So here in the first method, we easily get these two roots of the given equation, and now here in the next step we will be verify that is both of these roots are solution or extraneous root. For verification, we need to copy down given question statement. Here it is square root of x is equals to minus x. This is our given question statement, and here we verify both of these above roots. In this side we will be verify x is equals to 0, and in this side we will be verify x is equals to 1. So here first we focus on the root x is equals to 0, and we substitute it on both of the sides of the given equation. So when you substitute x equals to 0 into the left hand side, it will become the square root of 0, and we will put into the right hand side we get negative 0, and also we know that 0 be the neutral term, it is not positive or negative, and square root of 0 becomes 0 is equals to 0. Okay, so this shows that the value of x is equals to 0 is satisfied our given question statement because both of the sides are equal. So this means that x equals to 0 be the one solution of the given equation, and here we need to focus on this term, and here when you put this value here, it will be written as square root of 1 is equals to minus 1, and we know that a square root of 1 becomes 1 is equals to minus 1. So here we know about that this is not possible case, or it is not possible that 1 is equals to minus 1. Okay, so this is not possible. It means that both of the sides are not equal when we choose x is equals to 1. So the conclusion about x is equals to 1 is that x is equals to 1 be the extraneous root of the given equation. So here I can explain the term extraneous root. So the roots which is satisfied over given question statement is called the solution, like x is equals to 0. Okay, and the roots which does not satisfy our given question statement is called the extraneous root, in like x is equals to y, x is equals to 1, because it does not satisfy our given question statement. So this concludes that the solution set of the given equation is 0. So this is the only one solution of the given equation, and x equal to 1 be the extraneous root. And now here we move forward and we again solve this problem for second method. So for this we need to copy down given question statement here. So in the second method, we have the question statement is square root of x is equals to minus x. This is the our question statement. So in the second method, I can just give you a nice smart method or smart technique in which you can easily get the value of x. Okay, so here in this method, we just move this minus x to the left hand side, and it will be written as square root of x plus, this is x only, and we write this x as square root of x into square root of x, and in the right hand side we will get here a 0. And further in the next step, you see here both of these terms involve square root of x. So when we will take common square root of x, we get the remaining values are, from here we get 1, and from here we get square root of x is equals to 0. And now we divide this equation into the two cases. The first case is we write square root of x is equals to 0, and the second case is we write 1 plus square root of x is equals to 0. So here we take scaling on both of the sides. So when you will take scaling, we easily get the values of x is equals to 0 from the first case, and from here we move this plus 1 to the right hand side, and it will be written as square root of x is equals to minus 1. So in order to remove this square root sign, we again take a squaring on both of the sides. So these 2 and the square root are gone, and we get here our x is equals to the square of minus 1 becomes plus 1. So this is the second root of the given equation. So you see here from both of these methods we will get here the same roots of the given question. Okay, so we already verified these two roots into the first method. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.